Hello, ladies and gentlemen, and welcome to another wonderful lesson with Mr. Wheezy. So, continuing on with what we did yesterday, or not yesterday, but the last lesson, we talked about the different trig functions, how we can use those. Now we're going to specify just on right angle trig. So this is stuff that you've been doing before, although we've pretty much kept to just sine, cosine, tangent again. But we're just going to expand that out to the other three. So, kick off were the 6 trig functions. Well, we have our sine, our cosine, our tangent, and then the 3 that go with it: cosecant, secant, and cotangent. So those are our 6. So if you think back to the last lesson, when we were finding, say, sine and cosine here, we could use that unit circle, being the x was the horizontal, so the adjacent side, and y was the vertical, the opposite side, and did our sine of x, cosine of y, or sine of t, cosine t, which was y and x. Well, that's coming from this here because that radius then is 1. So opposite over hypotenuse, y over 1 is just y, and adjacent over hypotenuse, x over 1 is just x. So same sort of idea, but what we're really doing there is making that triangle with that unit circle, which is that right triangle, and that's what we're going to go into today. So let me jump into this other stuff. So it's kind of what I explained already there, is just we're using that figure to match up those values. And these are what they are. Let's see if I can go to there. Here we go. So sine is still that opposite over hypotenuse. So if you're looking at that triangle there, which is not on my screen, this was A, this is C, this is B, so this is little a, this is little b, this is little c. This really is that angle theta. So opposite over hypotenuse, opposite A over C, adjacent over hypotenuse, B over C, opposite over adjacent, A over B, and so on and so on. Okay, so that works too here for these other ones. Only notice how it's flipped over. So now it's hypotenuse over opposite. So C over A compared to A over C. That's all we're doing. We're just flipping those. So we'll find these first 3 like normal, and then we flip these here. So that normal way that we find them, think SOHCAHTOA. Sine equals opposite over hypotenuse, cosine adjacent over hypotenuse, TOA opposite over adjacent. Or opposite over, that should be adjacent, not hypotenuse. That is a typo. Sorry, guys. So, keep in mind, it doesn't matter the size of the triangle. As long as it's a right triangle, you will get these same ratios at that certain angle. So, whatever the size, it could be a 3 by 4 by 5, or it could be a gotta think here. What's another one? 3 by 4 by 5. A 9, 12, 15. Any of those. Anyways, the point is, it doesn't matter the size. You're going to get the same ratios no matter what. So that's where the trig functions come in. So we're going to use those and find some problems out. So first off, we're going to do the Pythagorean theorem here. So we can find the sides of a triangle if we don't know one of the sides. So if they just gave you 2 of the sides, so let's say they gave you A and B, and we need to find C, or they gave you B and C, you need to find A, whatever those values are. Just remember, you can always use that Pythagorean theorem to find that third side, and then you can do this right angle trig. But for now, we're going to do this with A being 5, B being 12, and C being 13. So we're a 5, 12, 13 triangle here. So, sine. If we look back up further in the notes, we have sine being opposite over hypotenuse. So in other words, A over C. So A over C. 5 over 13. Cosine, adjacent over hypotenuse. 12 over 13. And tangent, opposite over adjacent. So 5 over 12. So now this other set, we're just going to flip these over. So this becomes 13 over 5. This is 13 over 12, and this is 12 over 5. And you're done. It's going to be literally that simple. Now, if we have a square root, is the only time where then you'd have one more step where you're going to rationalize that. So take it times the square root on top and bottom to get rid of the square root on the bottom. But if it's just nice numbers like these, that's it. You're done. Now, that won't always be the case. So if I redraw that triangle now, so we're A, C, B, so little a, little b, little c. And notice how the side little letter is opposite of that angle. So B opposite, A opposite, C opposite. That's where I'm getting that from. But if we plug these in, so A is 1, B is 2 square roots of 2, and C is 3. Not another C, but a 3. There we go. So sine A over C, so 1 over 3, so 1/3. Cosecant CSE, flip that over 3 over 1, so in other words 3. Cosine adjacent over hypotenuse, so 2 square root of 2 over 3. So when we flip it, we'd have 3 over 2 square root of 2. Now all we have to do is just times by the square root of 2 in this case. We don't have to do the entire bottom. But what that's going to do is we're going to end up with 3 square roots of 2 on top. The square roots cancel. And so we just have 2 times 2, which is going to be 4 on the bottom. So square root of 2 times square root of 2 would just give you 2. And then times the 2 that was out front, you get your 4. Tangent now, opposite over adjacent. So 1 over 2 square roots of 2. And rationalize that. So you get square root of 2 over 4 again. Because again, square root of 2 times square root of 2 is 2. 2 times 2, 4. So then we flip this. We get 2 square roots of 2 over 1. So in other words, 2 square roots of 2. And again, it's done. It's really, this lesson hopefully should go fairly smooth for you guys. Shouldn't hopefully be too difficult or too time consuming. Hopefully that'll give you a little bit of a break. But that's literally what we're doing in this whole lesson here is just right angle trig, finding those sides. Keep in mind, here they're referring to A being this A angle as your angle you're working with, so that makes this opposite, adjacent, hypotenuse. Same thing on the top here. If I pull this down, this is really that angle they're going off of. Is how they're setting that up. So these are some of the more common ones. If we were still in class, these would be the ones that I'd be like, hey, put these on your note card because these are going to be ones you're going to use a lot. So 45 degrees, same thing as pi over 4 in radians. That's going to end up being square root of 2 over 2. Tangent is just going to be 1. Sine, same thing with 45. They're both going to be the same value there. Because on a 45, 45, 90, it's an isosceles, so 2 of the sides are the same. So both sine and cosine will give you the same value. 60 and 30, so 60 degrees, which is pi over 3 in radians. Sine is square root of 3 over 2. Cosine 1/2. Square root of 3 for the tangent. 30, which is pi over 6, is 1/2. Square root of 3 over 2, and square root of 3 over 3. Trying to think if we really get into this too much, this one, but you could always think back to where these are coming from are those special triangles, and I don't know if you remember those at all that we talked about in geometry. You had your 45, 45, 90. So that was your 2 square root of 2 square root of 2. And then your 30, 60, 90. So 30, 60, 90 is 1 square root of 3 and then 2. That's how those are all coming. That's the ratio of the sides, how they'd match up. But that's where really these here are coming from, are from doing these trig functions. These are just the shortcuts. These are the answers without having to go through, okay, which one's what. Because like if we did, okay, sine of 30. So at 30, sine would be opposite over hypotenuse, 1/2. That's where that's coming from. If you put them in your calculator, you'd get the same thing, although you'd probably get a decimal for like cosine of 30 because the calculator's not going to spit you out just square root of 3/2. But it would be the same value if you put them in. Now, kind of if you think back to what we just did there with sine and cosine, how those really tie together. They're really opposites of each other. Those are really going to be complements. Sine and cosine are complements. So sine is just going to be the same value as cosine of 90 minus theta. Because again, sine is opposite over hypotenuse, so A over C. So A over C. So 90 minus theta would be the opposite angle. That would give you that as well. So cosine 90 minus theta, also A over H, so A over C. So 90 minus theta. So if theta is, say, 47, well, that's going to give you this other side. Okay, so let's go this. So A is 47, that would make this one 43. Well, because this is 90 and 90 minus 43 is this. So if we're at cosine, which is adjacent over hypotenuse, that would be the same from this side of opposite over hypotenuse. So that's why sine and cosine are going to tie together. These are how the other ones will all go. So cosine is sine of 90 minus theta. That works same thing with degrees, I should say, not, with radians. You just replace pi over 2 with the 90. This is where I'm going with that. Cosine, tangent, cosecant and secant, tangent, cotangent, secant, cosecant. That's how they're all tying together. Those are the co-functions or complements. They're referred to the same thing there. But yeah, just replace 90 with pi over 2 when you're dealing with radians, and it's the same concept. You would do pi over 2 minus whatever your angle is. So to find some, the co-function here would be cosine, since we're dealing with sine, and it's going to be 90 minus the angle of 72. So in other words, cosine of 18 degrees would be the same thing as sine at 72. So that's how they're going to give you the same values there. That's how it's going to work together. Radians. So cosine goes to sine, and it would be pi over 2 minus pi over 3. Now, again, fractions, we have to get common denominators before we can do that. So sine, common denominator would be over 6. Well, I would take 2 times 3, so the top will be times by 3, so 3 pi over 6 would be your pi over 2. 2 times 3 again, so take the top times 2, so 2 pi. So in other words, sine of pi over 6 radians would be its cofunction. So a little more work when you're dealing with radians. You just got to get those common denominators, but you can find those that way as well. So let's apply what we've done here. So a lot of times, right angle trigs used to find angles of elevation, angles of depression. I've used them myself when I was in drafting to, say, find the length of the stairs, how long the boards will need to be for the sides of the stairs. You can do it for roofs, different things that way. We've used it when we were putting in new cattle yards. We had one cattle yard that we did that had a slant to it. So I figured out, okay, for this by this is what the slant's going to be. There's different ways that you can use trig in real life, and you can use it a whole lot if you really want to. So this is one place where it could be used. So deciding the top of a building. A surveyor measured the angle of elevation to be 22 degrees. The transit sits 5 feet above the ground and 300 feet from the building. Find the building's height. So number one, you may be asking, what is a transit? A transit is basically a scope like on a rifle, but it's tied to angles so that you can sight stuff in and then tip it to get the angles of elevation. And then you can work your right angle trig like we're going to do here to find out maybe heights of stuff or distances things are. That's really what a transit does. It keeps it from pivoting left and right. All you can do is pivot up and down with that scope just to get those angles of elevation. So here's our surveyor dude, and he's working with this transit here, which is set up on a tripod. He then is sighting in this building. Okay. He is then 300 feet from the building. And he is looking up to the top here, and he knows that this angle of elevation is going to be 22 degrees. I really should have drew my building closer so that it didn't look like we have parallel lines, but this is supposed to be a triangle here. So this is really what we're dealing with, is we'd have this here triangle. So here's our building side, here's our transit side, so our 22. We're wanting to know what is our height. 300 feet then is our distance. So, you need a trig function. What are we working with here? Well, we're working with an opposite of where our angle is, and we're working with an adjacent of where our angle is. Opposite and adjacent is tangent. So we're going to do tangent of 22 degrees equals our opposite x over adjacent of 300. And then we're going to solve from there. So since the 300 is on the bottom, we would take it times 300 to get it off the bottom. We're trying to get x by itself. So if we times that side by 300, we're going to have to times this side by 300. So we're going to put that in our calculator. First off, we have to make sure we're in degrees. So we're going to hit mode if you're dealing with T84 plus or any of my graphing calculators. If you have just basic calculator, you should have a degree radian. It's like DEG, RAD. I don't remember what the third one is. But you'll hit that to get it selected so that you're in degrees. So right now, mine was from radians from last time, so I'm going to switch it back over to degrees. So now I can get out of it by second mode or hit clear. Either one works. But I'm going to put this in. So 300 times tangent 22 degrees. So tan 22. So I get 121. So my x is going to be about 121 feet. Now, the only problem is that transit is 5 feet off the ground. So when it's perfectly level at 0, it's still 5 feet up what it's siting the building at. So we have to add that 5 feet in that the transit is sitting there. So that's why it ends up being 126 feet tall than building. So keep that in mind when you're working with this, that transit, we're not zeroing out at the bottom and getting our angle. That zeroing out is when it's perfectly level. So it's going to shoot 5 feet up on the building. Whatever height your transit is, that's going to be perfectly level. And that's your height. So, one last thing I want to do is just making sure then to go the other way to find what the angle is. You're actually going to use the inverse. So this would be tangent inverse of 21 over 25. So to find the side, you're just going to do straight up the tangent, the cosine, the cosecant, whatever there. To find the angle, then you have to use the inverse. So that when it's raised to -1, so sine inverse, so second sine, cosine inverse, second cosine, and then tangent inverse, second tan. Now, to do any of the other three, secant, cosecant, or tangent, you're just going to do 1 divide then whatever that matches up. So like cosecant, CSC goes with sine. So you would hit 1 over sine 22 or whatever. But to do this out, you would hit second tan and then 21 divide 25. And there you go. We get our 40 degrees. So that is this lesson. Next thing we're going to do then will be a quiz. Quiz should be in your bag. Now, technically, as you're going through and doing these lessons, if you want to work on the quiz right away while it's fresh, you don't have to wait till the day that it's assigned on Google Classroom. You can always be working on it a little bit ahead of time. Just giving you some heads up there. But that is it. So until next time, if you have any questions, comments, concerns, please pan me. But know that's going to be not the most speediest way to get an answer back. Google Classroom or email can be the faster ones. But please let me know and I will help you out as much as I can. But until next time, we'll talk to you later, guys.